Solve the following system of equations using substitution. And so equation 1 is x plus y equals 3. And equation 2 is x minus y equals negative 15. So with starting this one, we first see that both equations are simplified as far as they can go. So we immediately want to choose either one of the equations and solve for one of the variables. So I'll start with equation 1 here. So I am going to solve equation 1 for, you can solve for either x or y. So I'm going to solve for y. I'm going to solve equation 1 for y. So equation 1 is x plus y equals 3. And then to solve for y, I will subtract x from both sides of the equation. So x minus x goes to 0. And this gives us y is equal to 3 minus x. So we have rewritten equation 1. And now we're going to go ahead and substitute equation 1 into equation 2 and solve for x. And the reason we know that we're going to do that is we've isolated y here in equation 1. So we can take it and substitute it into the y of equation 2. We'll substitute equation 1, what we just found, y equals 3 minus x, into equation 2 and solve for x. So we'll start here by just rewriting equation 2. That's our x minus y equals negative 15. And again, we know we want to replace the y of equation 2 with the y of equation 1. So we're going to substitute that in here. So this will become x minus, we want to be careful to use our parentheses, 3 minus x, and that's equal to negative 15. So now we can go ahead and we want to be very careful here. We want to distribute this negative through to both terms within those parentheses. So this will become x minus 3, and the negative times a negative will produce a positive x equals negative 15. And then we notice we have two like terms, or two x's on the left-hand side here. So this becomes 2x minus 3 equals minus 15. And let's move this up a little bit. Oops. And now we're ready to continue solving here. So I will add a 3 to both sides of our equation. So I have minus 3 plus 3 goes to 0, which leaves us with 2x is equal to negative 15 plus 3 is minus 12. And then we can now solve for x by dividing both sides of the equation by 2. So I have 2 divided by 2 is 1. And we can even note here that 2 goes into 12 minus 6 times, which leaves us with x is equal to minus 6. So we have the x coordinate now of our intersection point. And so our second step, step 2, we can substitute this x equals negative 6 into either equation to find y. And so pick your favorite equation. I'm going to choose, I'll choose equation 1 here. Equation 1. So remember, equation 1 is nice because we actually rewrote that at the beginning to be y is equal to 3 minus x. And so we're going to go ahead and replace this x with the x that we just found, with negative 6. So this becomes y equals 3 minus a minus 6. So negative multiplied by a negative becomes a positive, which will be 3 plus 6, which leaves us with 9. So therefore, we have our y-coordinate, the corresponding y-coordinate, y is 9. And our beautiful final answer here is the coordinate point, or ordered pair, when x is negative 6, y is 9. And we can even put a little note here that this is the point where the two lines of the given system intersect. So these two lines intersect at negative 6, 9.